charge in Roman numeral in parenthesis. Clear? Like in this case. I'll give you 3 examples. Same examples, right? Pure ionic, no numbers, pure covalent with both non-metal their numbers and transition. Yeah?
Okay. Can you go over the last one, the transition?
Yeah. So this is iron. Iron belongs to here in the second center part of the periodic table, right? So this is ionic compound. This is ionic too, right? So when you have ionic compound, your name of element, first element goes as it is, the second ends with I. But when you have an element from the center part, then you need to mention their charge in Roman numeral. That's what you need to figure it out. Element belongs to this metal, here, right, or the center part. Here? Okay. So to find the charge, you need to open up the crisscross, right? So for example, if I have this, copper 2 chloride. Now you have a name. So what will be the formula? Cu2 like this? No. Look, this is copper 2, right? Copper 2 means you have this copper plus 2. This is the charge. And then chlorine, chloride, you know that, you have a rule for that. And then you do the crisscross. So this will be CuCl2, not CuC. Metal charge will go as a subscript for the other one. Right? So let's say if I give you something like this, potassium phosphate, what will be the formula? So in this case, you need to write down their symbol. Potassium, what is the symbol for potassium? K. And what is the charge on K? First group element. What one? Minus 1 plus 1? Plus 1. First group element has plus 1 charge, right? That's how we find out the charge. First group element plus 1, second group element plus 2, 17th group minus 1, 16th group minus 2, 15th group minus 3. Plus 1. Phosphate. Phosphate is a polyatomic ion.
Right.
And you need to memorize that, right? There is no rule for that. So PO4, what should be the charge? Plus 2. You can't have both plus. Negative 2. Incorrect. So if you have negative 2, what will be the formula? K2 PO4. If you see one of this option, you pick this one, answer is incorrect. Huh? No, based on what you have, this is correct. But reality, this is incorrect formula because this is not correct. So what should be the formula for phosphate? Now you need to memorize that, right? You have a question based on this. You need to memorize that. Phosphate, sulfate, sulfite, phosphite, nitrite, nitrate, all of them acetate. PO4 3 negative. That's phosphate. So K3PO4. That's the correct formula. Crisscross. K3. Right? This 3 will go here. K3 PO4 1. Okay. Any other question? So with one we did so many. Any other questions? I'm doing this sample. She has it?
She has it.
You have the sample final?
Yes.
Yeah. So I'm doing the. So any other questions for first 40?
31.
31.
Isn't like a strong acid should always have the weaker base, right?
Strong acid always have weak conjugate base. So 31. So open up question number 31. So you have which of the following is the weakest acid? Weak acid has a strong conjugate base, right? One has to be strong acid have a weak conjugate base. Acid has a conjugate base, conjugate acid base pair, right? Strong acid has a weak conjugate base. Weak acid has strong conjugate base. So question is, which of the following is the weakest acid? That means you are looking for strong conjugate base, right? Which of the following has weakest acid? So how do I know all these are weak acid? All of these are weak acid. How do you know that these all 5 are weak acid? From the Ka value, right? Ka is only for weak acid. There is no Ka for strong acid, right? For example, sulfuric acid. Is that a weak acid or strong acid? Strong acid. We do not talk about Ka. HCl, strong acid. H3PO4, strong acid. HNO3, strong acid. We do not talk about Ka for these cases. Once you start having Ka value, that means your given acid must be a weak acid. Only weak acid has Ka values. Since all 5 has Ka in the question, so they all are weak. Right? Now among weak, we need to find out the weakest one.
So should we look at the expression?
So lower the Ka, weaker the acid is. Higher the Ka, stronger the acid is. Higher the Ka, stronger the acid is. Right? So I'm asking you which one is the weakest one. So that means what value you're looking for? The lowest Ka. Now which one has the lowest Ka? Negative 10. Right? So that is the weakest acid. Right? So if I ask you among these 5, which one is the strongest acid?
-4.
Answer is A, -4, right? If I ask you which of the following has the strongest conjugate base?
Should be the B.
Should be the B,
Yeah, since
right? Weakest acid will produce the strongest conjugate base. Make sense? If I change the statement, which of the following will produce the strongest conjugate base? Then answer is B2, right? And if I ask you question, which of the following will produce the weakest conjugate base?
A.
A. Strongest acid will produce weakest conjugate base. And if I ask you arrange these 4 in the order of their increasing acidic strength. See, but one statement, one data gives you so many questions, right? You can interpret in any way. So arrange the 4 in the increasing order of their acidic strength. Increasing means start from the weakest to the strongest. So which will go? So what will be the order? B, D, C, A. Let's see. Beautiful. Right? Weakest to strongest. And if I do strongest to weakest, then reverse. C, A, C, D, B. Make sense? Okay. See, one question we covered so many concepts. And if I ask you write down the conjugate acid, how do you write down the conjugate acid? What do you need to do? To write conjugate acid of a given substance, what do you need to do? For example, SO3 to negative. What will be the conjugate acid for this? Conjugate acid for this? Huh?
SO3 to the -1.
-1. Right? To write conjugate acid of a given this is your given substance. So probably I'll ask you the question. The conjugate acid for the conjugate acid for this will be, you have 5 options, pick the right one. This is the right. To write conjugate acid, you need to add 1 hydrogen and charge should go lower by 1 unit. right? So to write, this is the number line. To write conjugate acid, charge will go in this way. This is for conjugate acid. This is charge. To write conjugate base, charge will go in this way. Right? Right? To write conjugate. For example, if I give you this substance, what will be the conjugate base of this? So you need to remove a proton. To write conjugate base, you need to remove a proton. So when you remove a proton, it will be SO3. What should be the charge? Charge goes in this way. You have -1. -1 to -2. Right? Make sure to finish your homework. See that? You did finish all of them? And first 3 homework, I gave you the extensions for that. Did you notice that? Yeah. Chapter 2, 3, 4, 5, 6, I gave you extension for that. Till tomorrow.
Okay, thank you.
Right? To write conjugate acid of a given substance, you need to add a proton and the charge should go in this way. And to write conjugate base, remove a proton and charge should go in this way. Right? So, for example, what will be the conjugate acid of HCO3 negative bicarbonate? Conjugate acid
H2CO,
H2CO3, and what should be the charge?
but no charge.
No charge. And if I ask you to write down the conjugate base for this,
CO3 2 minus.
CO3 minus.
It's
Right?
like acid, it's like, if you like, it's a donor, so like conjugate would be the reverse, right?
It depends.
Pretty much.
It depends. It depends what kind of substance you're dealing with. For acid, you need to add a proton.
And
For conjugate base, you need to remove a proton. Acids are always 1 proton higher. Acids are always 1 proton higher than this. Right? Now, this substance can accept a proton. This substance also has a tendency to donate a proton. What do you call this substance? The substance who can accept a proton as well as donate a proton. Substance amphiphilic, amphiprotic, right? Substance who has a tendency to donate a proton, substance who has a tendency to accept a proton. We call such substance amphiphilic, amphiprotic, right? Bad language, bipolar, right? Both ways. Amphiphilic, amphiprotic, right? Amphoteric. We did that, right?
Yes.
Yeah. Okay. Any other questions?
Professor,
30? 38?
6 times.
No, which one? Number?
38.
38. In exam you have 30 questions, not 40. Right? 30 multiple choice.
That is 4 points.
Professor, all of them,
4 points for each.
so all of them.
No, you have 2 sets, 2 parts, part A, part B. Same pattern as you saw in exam 1, 2, 3. You said 38?
Yeah.
Okay.
Cis trans.
Cis trans, okay. So for cis trans, you have to have a double bond, right? What do you call the compound that has double bond? Which family is that? Alkene. So you have to have alkene, right? Now this carbon has 2 bonds, so you need 2 more. So here is 1 and second, 1 and second. So for a double bonded carbon atom, you have to have one group must be same that you can use as a distinguished part. The other one can be anything. Let's say I'm having Z here and L here. So this is not a distinguished part. This is the distinguished part. Now if the 2 groups that are distinguishing between cis and trans, if they are on the same side, we call it cis. But if they are on the opposite side, we call them trans. Right? You have to have at least one same. These 2 can be same. So this is a cis based on A as well as Z. Right? Now both, you can use this as distinguished, you can use this as distinguished, because these 2 are same, these 2 are same. You have to have at least one same atom or group on each double bonded carbon atom. right? So this is a cis either based on this or this, and this is a trans based on A or based on C, right? So in 38, yeah. So answer is so distinguished part is either CH3 or H, right? So 38. Look at the option A. Look at the option A. Can you tell cis and trans based on option A?
No.
No. Right?
3 hydrogens.
Because you have a on one carbon atom you have both same H and H, right? Then based on that you cannot distinguish. Similarly, B you have all same, you cannot distinguish. You need to have at least one, right? Okay. Any other question?
Do we like further like
Any question up to 40? First 40.
Professor osmosis?
Question number? So what is osmosis? Let's do this first. Osmosis is a phenomenon that allows only the solvent to pass through semi-permeable membrane. Only in osmosis osmosis. So let's say water, right? It can be any solvent. So osmosis allows only solvent to pass or flow through semi-permeable membrane. Semi-permeable membrane. Only the solvent will flow. And from where to where? From high solvent, from high solvent to high solvent, let's say solvent is water. So wherever side you have high water, high solvent or high solvent concentration to low concentration, low solvent concentration, right? Just go by solvent. So let's say high solvent side to low solvent side, but if you're looking at the solution concentration, then low solution concentration to high solution concentration.
Solution, right?
Solution.
No solution.
If you look at the solution concentration, right? So think about that. Things always flow from lighter to dense, right? So if you have a 4% light dilute sugar solution and a very thick solution, right? Can thick flow easily? No. Only the light is going to flow. And light has more water, less sugar. Right? So low solution concentration to high solution concentration if you are looking in terms of solution. But if you are looking in terms of solvent, so high solvent to low solvent, right? So let's say if you have 0.5%, let's say sodium chloride solution here, and you have 2.5% sodium chloride solution here. So from which way to which way the solvent will flow? From 0.5 to 2.5. Low concentration, I'm looking at the concentration wise. Concentration in terms of percentage, right? Remember the different ways to represent the concentration: mass by mass, volume by volume, percentage method, and then we have a molarity. So I gave you percentage method here. So low solution concentration to high. 0.5% solution means you have a high solvent here and you have low solvent here. Free solvent, right? So this will keep moving. For how long this will go? This movement will go until they become equilibrium. And when they become at equilibrium, are you expecting any flow after that stage? So what do you call those solutions? Once they become equilibrium and there is no more isotonic solution, right? Once the flow will stop, that means the two solutions have same pressure. We call such solution isotonic solution. Before this, what do you call this solution?
From
The
this
one
side.
with
No.
high solvent, go with respect to solvent, it's all solvent, right? So this is hypertonic. And this one with high concentration, this is hypotonic. Right? Things always hyper to low. You cannot go, right? Hyper means you're already at high stage. You just need to calm down. Things always go from, if the solvent is going from this side to this side, that means this must be hyper. This must be hypo, right? You cannot go higher than that. You can just go lower, right? If you're already excited, there is no way that you can go more than that, right? You need to calm down. Hyper to hypo. Make sense? Okay. Well,
We get a little confusion like.
go ahead. What's the confusion?
No, you're saying this hyper on from the perspective of solution, right?
Look,
Or the
solvent goes from here to here,
Mhm,
right?
mhm,
Solvent. So for solvent movement, it's clear.
mhm,
From high solvent to low solvent,
Mhm.
or low concentration to high concentration, right?
mhm,
Since the solvent is moving from this way to this way,
mhm.
so that means this must be strong, high,
Okay.
so hyper, right? So we have three type of solutions in osmosis. We have three type of solutions. We have isotonic solutions, we have a hypertonic solution, and we have a hypotonic solution. Isotonic solutions are those where the two sides are at equilibrium. That means they have a same pressure. Same pressure, right? So once they have same pressure, we call it isotonic solution, right? But if they're not same, then that means one must be high, one must be low, and things always flow from high to low, right? So the one that has high pressure, we call it hyper. Now solvent is flowing from this, so this side must be hypertonic. This must be hypotonic. Clear now?
The concentration is thicker in the hypo side, right?
Huh?
Concentration is
Thicker.
more in the hypo side.
Hypo.
Yeah.
Hypo.
You're right.
Hyper has a low concentration,
Oh,
right? Yeah. So see, when you go by concentration, then low concentration.
Local.
That's why we always go with respect to solvent.
Okay.
So which side has a high solvent? Things always go from high to low.
Mhm.
High solvent to low solvent. If you want to go for solution concentration, then yes, reverse
Low to high. Okay.
low to high.
Okay.
Right? That's why, I mean, you can talk.
Oh, okay. Okay. Now it makes sense.
Right?
Yeah.
Who wins the election in India?
Um,
This is a very funniest election this time.
uh,
Modi wins, right?
okay.
So they are celebrating that they win, and Congress also wins, right? As
Yeah.
India, they lose, but they are also celebrating that we win. So who wins? Right? It's dependent upon in which context we're talking about, right?
Mhm.
So if you talk about with respect to solvent,
Mhm.
It's high to low.
if you talk with respect to solvent, it's low to high.
Okay.
You need to find out. Okay. Delete that part.
Which part?
Yeah.
Oh, the Congress part? Oh, okay, sure.
That was the example. Okay, any other question?
Can we just like, not just exactly the 19, like the process, the oxidation and reduction, like in general?
Okay, in general, okay. So oxidation reduction. Oxidation reduction, right? The best way to memorize the concepts which are relevant to each other, write down side by side. Take an index card. So what is oxidation in terms of electron? Loss of electron. Loss. How do you spell off?
What?
Okay. Loss of electron or electrons. Reduction must be gain of electron or electrons. Opposite, right? It can be one electron, it can be more than one. loss of electron or electrons, reduction gain, right? So if you write down in terms of reaction, at what side the electron will appear? Product side,
Product.
loss of electron, so it reduces. So electron appears on product side if you have a reaction. Product side. Here electron will appear on the reactant side. In terms of oxidation number, right? Number is a charge, right? So oxidation, this is your number line. This is 0. These are negative numbers. These are positive numbers, right? So oxidation follows this, right? Number increases, loss of electron. Reduction is this way, right? Goes the other way. Oxidation follow this number, reduction follow this number, right? Oxidation is gain, oxidation gain of oxygen. If it is gain of oxygen, oxidation must be loss of hydrogen. Gain of oxygen, oxidation is gain of oxygen, loss of hydrogen. Reduction must be loss of oxygen, gain of hydrogen. These are the right detail about oxidation reduction. All concepts, right? So now if I give you this reaction, Fe2 plus changes to Fe3 plus electron. What kind of process is this? Right? I see the electron on the product side. Oxidation, half reaction. I see the charge +2 to +3. +2 to +3. Charge is going this way. Oxidation. Right? Right? This is oxidation, half reaction or oxidation process. Oxidation process. In half reaction, whether it's oxidation half reaction, oxidation process, or reduction half reaction, reduction process, in half process you will see the electron. When you have a complete process, then you will not see the electrons, right? For example, this zinc plus copper sulfate gives you zinc sulfate plus copper. Is this oxidation half process?
No.
Is this a reduction half process? Why not? Because I don't see electrons. What kind of reaction is this? Single replacement, but let's say you don't have that option. Right? Now which species undergo oxidation? In every reaction, remember? All reaction, whether it's a combustion, combination, decomposition, single replacement, double replacement, they all go under one big category. What we call that? Redox. All reactions are redox reactions. All reactions. Why? Because they all involve exchange of electron. Right? They all involve exchange of electrons. Someone is losing electron, someone is gaining electron. Right? All involve redox. All reactions are redox. So this is a redox reaction. So now if this is a redox reaction, that means there must be a species that must undergoing oxidation. There must be a species that undergoing reduction. Now which one undergo oxidation here? Zn is? No. So what is the charge? So what you need to do? I cannot see electrons, so based on electrons I cannot decide. So this part is gone, this part is gone. Because these two are electrons. This is oxygen, hydrogen. I don't see oxygen, hydrogen, exchange of oxygen and hydrogen. Because sulfate is here, sulfate is here. Right? So what do I need to do? I have to follow this number, charge. So write down the charges on each item. So what is the charge on zinc here? Sajita? Sajita, right? That's not the charge. What is the charge? When you have an individual atom, consider individual as a bachelor. And bachelor is a free. And free has what charge? 0. 0. This is bachelor too. Free. Zero.
Yeah,
So what is the charge on copper here?
Zero.
So we know
No.
copper is in contact with sulfate now. Bond. Bond cannot have charge, right? Only bachelors are free. Married people are not free. Right? Compound is a marriage, right? Marriage you are not free. Must be having some responsibility. Responsibility goes in this direction in terms of charge. Charge on sulfate is -2 polyatomic ion. So copper should be
+2.
because it's neutral, right? So +2 here, +2 here, same. So now look at the charge. For zinc, I see zinc goes from 0 to +2.
Oxidation.
Zinc undergo oxidation. And copper +2 to 0. Reduction. Whenever you in a reaction, whenever you have oxidation, reduction must be there. Right? Sajita, free elements always zero charge. When you have a compound, then you need to open up the crisscross, right? Find out their charges. Okay. So we covered oxidation reduction completely.
So free elements, whatever is in that transition is in the middle, right?
It can be any free element. Look at that. Is this if I give you this reaction, if I give you this reaction,
This one, CuSO4. SO4 they call it
do you have a transition element now? Do you have a
No, let me check.
Okay. There's no transition element.
No.
Oh no.
No. So it's not about transition.
Whatever
Right.
the single element.
Whenever you have a single element, always. Single element means a single element. Is this a single element?
Yes.
Yes. When you have an element with another element, right? Element with another element, right? Remember the covalent. How do you make a covalent compound?
Non-metal, non-metal. Non-metal, non-metal.
It can be non-metal.
non-metal.
Yeah. When you have an element with another element, right? Then you may or may not have charge. If it is ionic, it's always charged. If it is covalent, then you need to look up their electronegative values. Right? So here you have a two elements, but both are same. So electronegativity is 0, so charge is 0. Right? Or let's say when you have a one type of element, whether it's alone or combined with their own type, charge is always 0. Right? So aluminum 0, hydrogen 0. What is the charge on aluminum here? +3, because chlorine is -1, so crisscross, open up the crisscross, right? +3. So now I can see aluminum undergo oxidation. Aluminum undergo oxidation. What kind of agent aluminum be? Agent. The substance who undergo oxidation is a reducing agent. So aluminum is a reducing agent. Substance who undergo oxidation is a reducing agent. And who is here? Chlorine is -1, hydrogen is +1. Here chlorine is -1. Right? So which one is the oxidizing agent here? It's not HCl. It's hydrogen in HCl. Hydrogen undergo change. Chlorine is -1 here. Chlorine is a spectator ion. Right? If I write down the ionic equation for this one, I can say aluminum plus H positive plus Cl negative. Make sense? Right? And then I will balance it. Now this is the balanced equation. Right? And it's not balanced. 6, 2, 2. Now it's balanced. Right? But who cares about balancing? Forget about balancing. So I have this aluminum 3 positive plus chloride, and if you want to go for balancing 6, this will be 2, this will be 2, and this will be 6. 2 plus H2 as it is. So you cross out 6 chloride here, 6 chloride here. Peptidine, right? It's a hydrogen in HCl. Okay. Thursday we have exam at 11 o'clock. Right? 11 to 1. 2 hours. So make sure you have your calculator. I will not allow you to use cell phone or right? Any other calculator. Okay. What next? Out of first 40. Huh?
Can you go with the 39?
39. The carbohydrates shown here as classified. So remember the classification of carbohydrate? One classification we did it based on their taste and solubility. Right? So based on taste and solubility we have sugars and non-sugars. Then we did the second classification based on how many types of carbohydrate units we have. Monosaccharide, disaccharides, polysaccharides, right? So in case of disaccharides and polysaccharides, the bond by which the carbohydrate units join together, what do you call that bond?
Glycosidic.
Glycosidic bond, and the process to break down is glycolysis, right? Now between the monosaccharides, we classified further based on types of functional group they have. If they have aldehyde, we call them aldoses. If they have a ketonic group, this is aldehyde. If you have aldehyde, we call them aldoses, and this is aldehyde. One side is free, one side is hydrogen, and this is always on terminal. Right? And if they have a ketone, we call them ketoses. Ketone, aldehyde. Right? Now, further, depending upon how many carbons they have in the chain. If they have a 3, we call them aldotriose. If they have a 4, aldotetros, aldopentose for 5, and aldohexose. 3 to 6, that's it. Aldotriose, aldotetros, aldopentose, aldohexose. And if they have ketonic group, then ketotriose, ketotetros, ketopentose. Now in this one, how many carbons do you see?
1, 2, 3, 4, 5, 6.
6. So this means this must be hexose. So any option that does not say hexose is out, right? And now what kind of functional group do you have? Ketone. So this should be ketohexose. Clear? Okay. So if I remove the 5th carbon atom, if I remove that, for example, this is what you have: CH3, CH2OH, C double bond O, CHOH, CHOH, CH2OH, right? This is what you have. 1, 2, 3, 4. Just one carbon atom. One, 2, 3, 4, 5, 6, right? So if I remove this, then it will be ketopentose. But if I remove this and I put C, let's say HOH here, and then I do CHO here, aldopentose. So now you have aldehyde and 5 carbon atom. Right? So depending upon what kind of functional group you have and how many carbon atom, we have aldotriose, aldotetrose, aldopentose, aldohexose, or ketotriose, ketotetrose, ketopentose, ketohexose. Okay.
Can you add to that?
I just did it. Aldo, right? So you're looking for aldehyde group, CHO, that's the aldehyde, and it has to be on terminal. Pentose, so that means 5 carbon atom, 2, 3, 4, 5. Right? If I give you this C12H22O11, right? C12H22O11, what kind of carbohydrate it is? Aldotetrose, aldotriose, aldotetrose, aldopentose, aldohexose, ketotriose, ketopentose, ketohexose, keto. What type of carbohydrate is this? Impossible to tell. Right? What do you need? You need a structure. You need a structure. If I give you a compact formula, based on compact formula, you cannot tell. Point number 1. Point number 2, you cannot tell because triose, tetrose, pentose, hexose, and that's it. That means from how many carbon atom to how many? 3 to 6. How many carbons we have?
12.
Right? Right? If I give you this C6H12O6, this is the formula for glucose or fructose. Right? So this is hexose, but I don't know whether it's aldehyde or ketone. So what do I need? Structure. I will give you the structure and then I will ask you options like that. I cannot give you a formula and ask you to identify that, right? But based on formula you cannot. You need to see the functional group. Right? You need to see the functional group. Right? Yes, I can give you this question. Glucose is a carbohydrate that has an aldehyde group in them. Glucose is a carbohydrate, then it has an aldehyde group in it. What kind of carbohydrate it is out of those? Because I told you it has aldehyde and then it has 6. So aldohexose. Then you can tell. Right? I have to tell you the functional group. Fructose is a carbohydrate. This is the formula for fructose too. Fructose is a carbohydrate that has ketone group in those. Right? Then what kind of carbohydrate, what kind of monosaccharide this will be? Ketohexose. This is galactose. Galactose is a carbohydrate. This is galactose is a carbohydrate that has aldehyde group in that. What kind of carbohydrate it is? Aldohexose. I have to tell you the functional group. Then based on number of carbon atoms. Carbon atom goes from 3 to 6 and that's it. Period. Okay. And one question we covered so many things. That's why I asked you to do it. Yeah, go ahead. Yeah, you can do butterfly. You can do mole to mole, mole to gram, gram, mole to gram. You can do gram to gram. Tell me the reaction. Okay. Tell me the reaction. C2? C2H2? Okay. Carbon dioxide plus water. So this is the reaction, a question on reaction stoichiometry. Let's first of all, equation will be given to you. You make sure equation is balanced. This is balanced equation. What type of reaction is this? Type of reaction. Combustion. When you have oxygen as one of the reactants, it's a combustion reaction. right? This is combustion reaction, it's not balanced, so let's balance it. 2 carbon, 4 oxygen, no, 2 hydrogen, oxygen 4 and 5, so it has to be 5 by 2. So you need 2 here, 4 here, 4, balance. What happened?
But you need to say, yeah. One by one.
When it comes to 2 in the front,
When it comes to odd number, it was 5 by 2, right? When you have odd number, multiply everything by 2. So 2 by 2 cancel, 5 left. Look at it, right? Balance all the atoms other than hydrogen and oxygen. That's what the rule we did, right? So which is carbon. So 2 carbon, 2 carbon. Carbon is balanced. Clear?
Yes.
Now we just left with the hydrogen and oxygen. There is no specific rule for that. Let's balance which one is easy. 2 hydrogens, 2 hydrogen. Hydrogen is balanced. Let's go by oxygen now. Hydrogen is balanced. Right? How many oxygen I have here? 5. How many oxygen I have here?
2.
5 means odd number. Right? So how can I make 2 into 5? Can I just do 5 by 2? So 2 cancel with 2. Now 2 cancel with 2. That means I have 5 oxygen. Right? To make 2 into 5, I need to multiply by 2.5. 2.5 times 2 is 5. 5 oxygen, right? But I cannot do 2.5 atoms. So 2.5 is nothing but 5 by 2. Make sense?
Yes.
So if you have a fractional number, if I multiply everything by 2, so 2 will be here, this 2 to 2 cancel, this 2 will become 4, and this will become 2. Right? It's balanced now again with a non-fractional number.
So Professor,
Right?
every time we have to balance the C and H before.
That's what the rule is.
Oh, I didn't know about it.
Balance, it's not a rule, but it's my analogy to how to balance it. Balance all the atoms just to make the life easy.
First C and H, right?
Balance all atoms first
Oh.
other than hydrogen and oxygen.
hydrogen, oxygen last year.
Oh.
Balance hydrogen and oxygen at the end.
And
Whatever you have, a chlorine, a potassium, magnesium,
Those
aluminum,
first?
iron, balance these first.
Okay.
When you balance these elements, one of these elements, hydrogen and oxygen, they're going to be balanced on their own. If not, then balancing these two is much easy. Right? Okay, so now what was the question? What is the question now?
Question is like why you in Q use the gram to gram conversion for K.
Okay. So let's say if you have a question like this, and the question is about reaction stoichiometry, right? One amount of this, one this, any two reactant, any two product, right? First of all, equation will be given to you, you balance it. Once you balance it, then whatever number you see in front of those, these are moles. So I can say I have 2 mole C2H2, 5 mole of oxygen, 4 mole of carbon dioxide, 2 moles of water. Right? So I can make a reaction. Remember, a question based on reaction stoichiometry, this is the formula you will use. Need is equal to given times conversion factor. Right? You will be having a need in the question, you will be having some given in the question, you need to prepare conversion factor. So you can make conversion factor between mole to mole. Mole of anything, right? Mole to this, so I can see 2 mole of C2H2 is equal to 5 mole of oxygen. One equality. I can compare these two, I can compare these. Make sense? You can make mass to mass. So 2 mole. What is the molecular mass of C2H2?
H.
24.
24 plus 2, 26. Right? Since you have 2 moles in the equation, so this will be 2 times 26 is 52 gram C2H2. This will be 32 times 5, 160. 160 gram O2. Right? 160 gram O2. This will be 176 gram CO2. This will be 36 gram water. Make sense? Molecular mass of water is 18 times 2, whatever coefficient you have, 36. Carbon dioxide 44 times 4, 176 gram. Oxygen 32 times 5, 160. C2H2 24 plus 2, 26 times 2, 52 gram. Right? So I can make an equality. If the question is asking you how many moles of this will be produced from this many mole, so now you need an equality between mole and mole. Right? If the question is how many grams of this will be produced from this many grams of both the entity, grams of need, grams of given, then you will make gram to gram equality. Right? Moles of need, moles of given, then you need a mole to mole. Right? But if you have a mole to gram, then you can do this mole to gram. 2 moles CH2 160 gram. Mole to gram equal, right? Mole to gram. Mole to gram. Mole to gram. Mole to gram. Butterfly. Is a butterfly.
Yeah.
Right? You can do mole to gram also.
But then I don't understand why we have to go through all this. Why don't we just do compromise? Again,
Who said that?
it was the question, sir.
Yeah, so that's what I told you. Did I when I was doing this in the class, was I following the slides? No. Because slides have those detailed process. And I told you you can do this. You can do the detailed process. Look at that. I need to reach here, right? I can do this to this and then I can go here. Or I can just go here. Right? That's why I told you when you go for tutoring, they will tell you go this. Different people have different ways to do. You can do this, butterfly. You can do mole to mole, gram to gram, or mole to grams. Right? Yeah, okay. Any other question? Huh? I can do that. So simple. When you write conjugate acid, add proton, and when you write conjugate so one more time. When you write conjugate acid of a given substance, let's say I have HS negative. Another example. I didn't do this example before. When you write, this is the substance given to you, and question is writing conjugate acid for this. What you need to do? To write conjugate acid, add a proton, add hydrogen. If I add hydrogen, I will be having 2 hydrogen, 1 sulfur, right? To write conjugate acid, and charge will follow this direction. These are negative numbers, these are positive numbers. Charge will follow this direction. So I have -1, next -1 to 0, so no charge. When you write conjugate base of a given substance, remove a proton. When you remove a proton, you just end up with sulfur. Now what should be the charge? Charge will follow this direction. This is conjugate acid, this is conjugate base. So what should be the charge now?
-2.
Negative.
Can you write the exhibition based on that, like we can know which one is conjugate acid base? In the exam, if you give like equation, right, we have to identify which one is conjugate base. Can we do that?
Ammonia plus OH negative gives NH2 negative plus water. Right? So if you have an equation, what do? You need to make a pair first, conjugate acid base pair. So who do you want to pair this? One comes from reactant side, one comes from product side. So you need to pick one from the product side that correlates with this. Which one you will pick? This one or this one?
And
So this is your pair, right? right? So in this pair, the one that has more hydrogen is acid. Which one has more acid, more hydrogen? Reactant or product? So this is your acid, the other one should be a base.
I know this, but when you write like this, it's
Yeah,
confusing.
that's true.
Like when you're in equation, it's easy like to identify. Usually, like base has only.
This is equation 2.
No, but but in the exam you give like this and we
Yeah.
have to identify.
That's why I told you. If you have a given substance, what will be the conjugate acid of this? Right? So to find the conjugate acid of a given substance, add a proton. So if you add proton, you will be end up with H2SO3. What should be the charge?
Positive.
Charge on this. Charge follow this direction. -1 to 0. This is the conjugate acid. Right? They did not always ask you to do the reaction.
Sorry. I have a question on this.
Yeah.
In the exam, you know, like
Which question? Sample exam?
Yeah.
Okay, what is the question number?
It's like
Question number.
at the end, I cannot remember. This
Say the number. Say the number.
number 40.
40.
Yeah.
40 is not that question.
Which one? 40 is multiple choice.
That's not conjugate acid base pair. 40 is polyunsaturated fatty acids. Right? Fatty acids. So for fatty acid you need a COOH. You need acid and you need a long chain. Long chain. So this is fatty acid. Right? Fatty acid can be saturated, can be unsaturated. Is this a saturated or unsaturated? Saturated. If you have all single bond, then it is saturated fatty acid. But once you start having a double bond, then it becomes unsaturated. Among unsaturated, you have monounsaturated or polyunsaturated. So if you have one double bond, monounsaturated, but if you have two or more, then it's polyunsaturated. So the question is, which of the following is polyunsaturated fatty acid? So what is the answer? B. This is the definition. Instead of asking you to write down the definition, because sometimes it's very hard to read your handwriting, I gave you the answer, pick the right one. I'm sorry for my harsh words, but sometimes it's not easy. One of the student in this class, when he or she wrote the exam, the font size was a 2. Think about font size 2. How can you read it?
You need a magnifier.
So tiny, isn't it?
Yeah, so tiny.
You need a
If I need to spend 10 minutes to grade your exam, I need 1 hour to grade that exam. I was complaining, can you write down big? Can you write down big? It's a handwriting, right? I can't change the handwriting. And it's so damn hard for you to change. That's why practice. So what happens these days? You don't write down on piece of paper. That's why your handwriting is not that great. Right? But when you start writing more, because you don't write, right? You don't write. So when you don't write, your handwriting is not.
No, it's like, the exam is like time constricted, right? So like your handwriting goes like haywire.
It's okay, but then it should be readable. If I can read, and if you need more space, you can always use extra page, right? If your answer is way too big, don't just compact, right? 500 words in one line.
Doctor's handwriting?
Then you need to ask the doctor to give you point. Any other question? Question number?
Number 29.
Number 29.
700.
You will ask the same thing again. You just said that.
Oh really? But this is not the question.
Conjugate base.
29 conjugate base.
I know, but can you do it? This is like given.
Yeah, if I'm hungry, what I'm going to eat, anything that comes to
No, I'm very confused this one. So.
HPO4 2 negative, right? This is the given substance. The conjugate base of this, to write conjugate base, what is the process? What is the protocol? Huh?
Adding.
No,
To write conjugate acid, you add
That's
proton.
the acid.
To write conjugate base, what do you need to do?
You have to remove the hydrogen.
Remove
and
proton, right? You become a doctor, you become a nurse and you say that I know how to take the temperature, but I learned with this patient. I don't know with this patient. You learn the protocol, right? To write conjugate acid, you add one more hydrogen. To write conjugate base, remove a proton. So if you remove proton, what you left with?
PO.
What do you left with when you remove hydrogen from this?
PO4.
PO4, right? And now the next question is about what should be the charge. Charge needs to go in this direction by 1 unit. So you are already -2. -2 is here. -2. This direction. What will be the next number?
-3.
That's it. So pick this one from the option. That's structure. Right? So now you know how to do that, right? Anything. Okay. Yes, go ahead. Yeah, it's your turn now.
I have a question regarding on the periodic table. It's question number 8.
Question number 8.
Yeah. Why E is not correct? Because I thought the atoms are arranged in different order.
Okay. Which of the following is a characteristic of modern periodic table, right? So the periodic table that you see, that is modern periodic table.
So why E is not the answer?
Atoms are arranged in the increasing order. That was the first periodic table, Mendeleev periodic table.
But the periodic table that we use is
C is the right answer.
Go ahead. Go ahead, yeah. The periodic table that you use, also based on mass, right?
Yeah.
Do you have all of them there? No. What about the isotopic substance? Do you have a deuterium there? Mass of deuterium is a 2. What is the atomic mass of hydrogen? 1. What about deuterium? What is the mass? 2. 2. Do you have 2 there? Atomic mass. It could be the option E for question number 8. It could be the option E. But if I change the statement, which of the following is the characteristic of Mendeleev periodic table? Then it's E, right? But Mendeleev periodic table is a history. You don't use that. What do we use these days as a modern periodic table? So history is history. This is chemistry. This is not history. But we learned history, right? Mendeleev is the first one whose periodic table is based on atomic mass. We don't use that anymore. Right? Modern periodic table is based on atomic numbers. Hydrogen has a number 1, deuterium number 1, tritium number 1. All three number 1, that's why they are together. Yeah? What else?
In the exam, right? In exam 2, you said that you give a question, like, let's say CL4, and then we have to know, like, polar bonds and polar molecules. So it's like,
So I will give you the electronegativity table also.
no. Can you, like, sometimes you said that we have to, write, like, check for the electronegative bond, and then molecule, like,
To find what?
to identify if it's, like,
Whether the bond is a polar or non-polar?
and
Bond.
then what molecule is it? Polar molecule?
Polar molecule now, okay. So first of all you need electronegativities, right? So based on if the electronegativity E and D electronegativity difference is 0, more than 0 but less than equal to 0.4, then it is
Non-polar.
non-polar. If it is more than 0.4 and less than 1.8
Polar.
polar, non-polar covalent bond. I'm using CB. Polar covalent bond, right? If it is more than 1.8 ionic, we do not talk about polarity in this case. So polarity goes here and here. Non-polar or polar. A covalent bond can be polar or non-polar. Ionic is always polar. Ionic is always polar. So there is no doubt about ionic bond. Always polar. That's why we don't talk about those. So the question is about these. So now I will give you the electronegativity, and based on that you can find out whether it's polar or non-polar. For example, carbon hydrogen. Carbon electronegativity 2.1, hydrogen 2.0. How much is the difference? 0.1, and 0.1 goes here, non-polar. So this is non-polar. If you have this is non-polar, this is non-polar, this is non-polar, this is non-polar, all bonds are non-polar, molecule will be non-polar.
So if it says bonds, then we have to do electronegativity, right? Now there is a question about this.
Ammonia molecule is right, and I give you the bond as well as molecule both. So you're looking for both. So in case of ammonia, listen. Your friend dropped and then it was you or it was someone else? Who are those girls? They always talk with each other. Ammonia, right? So what you need to do, nitrogen, electronegativity of nitrogen is 2.1, hydrogen, and nitrogen I guess is 3.0. So how much is the difference? 0.9. So that means the NH bond is polar. So ammonia has a polar covalent bond. Now what about the molecule? So for molecule, what do you need to do? You need a shape of the molecule. Ammonia has 4 electron groups, 3 bond pair, 1 lone pair, right? 4 electron group with 3 bond pair, 1 lone pair. What kind of geometry? Trigonal pyramidal. So here is your trigonal pyramidal. Trigonal pyramidal geometry. Right? So when you have trigonal pyramidal geometry, molecule will be. So are these dipoles, are they balanced? Forces are balanced? So molecule will be polar molecule. Forces are not balanced. When forces are not balanced, then molecule will be polar. So polar covalent bond, polar molecule. Right? Polar covalent bond.
ENT도 가르쳤어. 이제 N도 가르쳤어. 엘렉트로네게티브 디프런스가. 내가 썼던 ENT도 써매줘야 가르쳤어.
이런 non-polar set, polar set, ionic with 슈퍼 이 건설기 charge test anti가
Activity, shoes, 어디 운나요?
그래서 electronegativity 이 number ED야 셔발이 돼 셔발이 태라 가전 하이드 따라
What difference? Lower. Oğlum ya. Tut var. Tut. Değil. O Dimash.
Electro negativity
Yo.
그걸 저거 있으니까 가족 사이도 때 그지 제 말하는다 난
Diran'ı sarı. 얘네 하고
나는 가족 사이 때
EMT 하고
Yes. Sorry. Yeah.
아니 그냥 하고
39.
Same like this, but it's 2.5 portion.
아니 1.8
The carbon tetrachloride molecule is okay. So another question, same thing, right?
Mm-hmm.
So CCl4 molecule. So
CCL.
you have 4 options: polar covalent bond, polar molecule, polar covalent bond, non-polar molecule, these kind of options, right? So CCl4.
CCL4.
So CCl, first you need to draw the molecule. Let's say this is the molecule, right? Lewis dot structure. Lewis dot structure. So what kind of bond is this CCl bond? Carbon is 2.1. Chlorine is 3.5.
Chlorine 3.0.
3.0?
Mm-hmm.
Okay, 3.0. Carbon 2.1.
Carbon, yeah, 2.5.
Carbon 2.5?
Mm-hmm.
Okay. 0.5. So 0.5 means?
Polar.
So you got carbon chlorine bonds are polar covalent bond.
Yeah.
Polar covalent bond. And now about the molecule. So any option that says non-polar covalent bond, those options are out, right? So you have a polar covalent bond. And now you're looking for a geometry. So you have 4 electron groups around carbon atom and all are bond pair. So what should be the geometry? Tetrahedral. Right? So this is your tetrahedral geometry. So remember I told you, when you have a 0 lone pair on the central atom, always non-polar. Because geometry is symmetrical. Symmetrical geometry, right? Remember when you have the electron groups, 2 electron group appear as 2 bond pair, 1 bond pair, 2 bond pair, 0 lone pair. 2 electron groups are linear, right? Linear. When you have a 3 electron group appear as 3 bond pair, 0 lone pair, 2 bond pair, 1 lone pair. Right? When you have 4 electron group, it appears as 4 bond pair, 0 lone pair, 3 bond pair, 1 lone pair, and 2 bond pair, 2 lone pair. Right? These are the possible combinations. I'm just removing this one. 3 and 4. So when in between 3 and 4, when you have a 0, geometry is always non-polar. For 0, always non-polar. And for these one, always polar. Right? These ones always polar. Polar. So this one is 4 electron group, 4 bond pair. This is non-polar. Polar covalent bond, non-polar geometry.
But without looking at those equations, like, I mean, the things that you written, right? Just by looking at the
Impossible.
the driver,
No.
Impossible.
we cannot.
No.
Mm-hmm. No,
Cannot.
you're talking about the trigonal planar which has the.
My dear friend,
Oh, okay.
this is a 3-dimensional geometry.
I
Right?
was thinking like a.
Yeah, that's what you need to think. Give me the pen. Look. This is what you have.
Let me check.
Look at that. This is the geometry. So, who is strong here? Chlorine is strong, right? So center is carbon. You're not interested in listening, or are you?
Sorry.
This is up. This one is up. That one is up too. So 3 up, right? So down. Sorry, not up. Down. Chlorine is here. So 1 down, 2nd down, 3rd down, 3 down, and 1 up. Right? 3 down, 1 up. Is that a balance?
No, it's not.
No, because these are dipoles, these are vector quantity. So when you have a 3 down, 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 right? The resultant of these 3 is here. Resultant, right? And the 4th one is here. So now what do you see? 1 here, 1 here. What do you see?
Oh yeah. That's
Balance.
balance.
This resultant has the same magnitude as this one. That's why they are balanced.
Okay.
Right? It's not, it's a vector quantity. Take whatever is yours. It's a vector
polar?
quantity, non-polar.
But only in linear. Only in the linear case.
Linear case, you can see that whether the forces are balanced or not.
The linear can be polar and non-polar.
Yeah. For example, HC, carbon dioxide is non-polar because one is here, one is here, right? But if you have HCN, H and C bond is nothing but Cn is here. So force is in this way, so it's polar.
It's just that like 0 lone pair is always more polar, right? So, when you look at CCl4,
Yeah.
so like a bond, right? There is no lone pair.
There is no lone pair, you need to draw the Lewis dot structure.
Yeah, then why is put like a polar?
Polar bond,
Oh,
non-polar molecule.
Or
Molecule.
Molecules they just and the structure
So in that, if it has both bonds, electronegativity and a molecule makes, we have to look at the shape.
I cannot hear you. Their sound is much more.
Now, if it's bonds, then we have to calculate electronegativity.
Electronegativity difference.
Molecules and shape.
You need to look for the shape. Yes.
I'm saying because I got since Cl4, right? Cl4 means Cl electronegativity is 2.5. You don't have to multiply into 4, right?
No. It's a each one. Yeah, each one. Michelle, no question for you? Fatima. Okay, yeah, go ahead.
For CCl4, for CCl4 there is more than 4 elements, right? There's 5 elements in CCl4. That could be always a tetrahedral if it's more than 4 elements.
Electron groups you are looking for. Electron groups. Remember what you need to do? Bonds. Bonds are electron group. If you have a 3 bonds, 3 electron group, then you have a trigonal planar, you can have a trigonal pyramidal. That's why you need to look for the electron groups. And what are electron groups? Electron groups are around central atom. Electron group. Who contribute towards electron group? Bond pair. Each bond pair represent single bond, double bond, triple bond. They all work as one electron group. Lone pair also on the central atom consider one electron group. One lone pair, one electron group. Right? So here I see 4 single bond when I draw the Lewis dot structure. So 4 single bond means each single bond 1 electron group. So you have 4 electron groups. When you have 4, then your expected geometry is right? Which is called electron group geometry. Is a tetrahedral. Right? That's what your expectation is. Do you have it or not? If it is 0 lone pair, then yes, expected and reality is the same. But if you once you start having lone pair creates a distortion in the family, like they are doing it, right? Distortion, disturbance in the class, doing disturbance in the class, right? And disturbance creates problem.
That's why H2O is polar, because it has.
H2O is a polar bond, polar molecule. H2O If I draw the Lewis dot structure for H2O, this is the Lewis dot structure. Okay. If you have a question, ask me. H2O, right? This is the Lewis dot structure for H2O. I see one electron group, one lone pair, one lone pair. So I see 4 electron group, right? Each bond represents, single bond represents 1 electron group, right? So 1, 1, 2. Each lone pair represents 1 and 1. So I got 4 electron groups, but they are in the form of 2 bond pair, 2 lone pair, 2 bond pair, 2 lone pair. So the name of this geometry is bent V shape. So I have a polar covalent bond. Geometry is this. So based on geometry, I can see one dipole here, one dipole here. Forces are not balanced, molecular. Polar covalent bond, polar molecule.
And sorry, organic, right? Organics are non-polar. So non-polar dissolve in non-polar, polar dissolve in polar. Understand?
Your words, not mine.
Light, light is the light, right?
I mean, polar dissolve in polar, no?
Polar dissolve, like goes with like, yes. Polar dissolve.
Polar dissolve in polar.
Organic is supposed to go with organic, right? Vinegar, acetic acid, is it organic or inorganic compound? Organic hydrocarbon. Does acetic acid dissolve in water? Yes, right? Like dissolve like, right? Bad example. Bad go with bad, good go with good, right? Sometimes good also make friends with bad people, right? Exceptionalities are here. Organic supposed to dissolve with organic, yes they do, but some of the organic compound also dissolves with water. Why? Because they make hydrogen bond, right? So exceptionalities are there. Does all organic dissolve in water? No, because they need to go with organic. Some of them goes with inorganic too, because they have something else, right?
Like how about oil?
Oil is insoluble in water.
So,
Oil is non-polar.
but what are the like solvent that can dissolve in oil?
So oil is organic, needs to go in organic solvent. So it can be benzene, toluene, hexane,
Okay, so
any organic solvent. All organic are miscible with organic. Some of the organic are also miscible with inorganic. Right? Clear? Okay. Go ahead. Any other question?
is there any question on proteins?
Is there any question on
Proteins like tertiary, secondary.
protein structure? No.
Yeah.
Definitions are important. What are the monomers for protein?
Monomers for protein?
Amino.
Alpha amino acids. Okay. Make sure to do practice question on pH calculations. Right? Acid base titration question. M1 for acid base titration you will use M1 V1 over N1 is equal to M2 V2 over N2. Right? N1 and N2 comes from balanced equation.
Coefficient.
Moles of acid. Let's say if you use this acid, this is molarity of acid, volume of acid, moles of acid. This is base, molarity of base, volume of base, moles of base. If this volume is in milliliter, this needs to be in milliliter. If you change this to liter, this needs to be in liter. N1 and N2 value comes from the balance equation. Yes.
So it has to be like liter all the time or no?
Doesn't matter.
No.
If this is milliliter, this should be milliliter. If this is liter, this should be liter.
That's what
Same
you
units.
asked for. Okay.
Same units. Yes.
So in the review you already balanced, that means you don't have to balance.
Yeah, if I say balance, it's balance. If I say unbalanced, it's unbalanced. Then balance it first. Right? And if I don't say, make sure it's balanced.
Give us a balance.
I will kill two birds with one stone. Two concepts.
The last bonus question.
And the last question, I learned in high school that there is in the lipids there is keyword. So is there a question?
Steroids has those tetracyclic structures. You have a 6-member ring. And then you have a 5-member ring, something like this. When you have 3 cycles and one 5-member cycle, that means you have steroid nucleus. And then this is the periphery, you can have anything on the periphery. This is steroid, it's one of the lipid, right? Lipid has a classification, wax, fats and oils and steroids. So fats and oils are not steroids, those are lipids. Steroids are also lipids, but they have to have this kind of structure. Cyclic structure. Okay.
Oh, but with the 5, one of the 5, right?
One 5-member, 3 6-member ring. Any question from part B?
How many bonus would be there? Like 5 or 10?
2 questions, I think 2 questions. I don't remember. 5 points each.
Oh, that's it.
2 questions, 5 points each. I think so. Yeah, I don't remember. It's been a couple of weeks.
What question is that?
Good question, good question.
One question based on your recording it, so I can't tell you.
No, it's okay. I can.
Maybe you can just give us a question. That's a given.
You will see whatever we did. You will see plenty of question based on that.
Move forward the organic compound like the structure equal
Question number. Okay, look at the question number 36.
36.
Question number 36. Which family compound A? Option A. Which family is this? Question number 36.
Oh, alcohol.
Carboxylic.
No, it's not alcohol.
I'm not looking for question number. I'm just looking for. Look at the option A. This option A belongs to which family?
Carboxylic.
Carboxylic acid. Option B.
Ether.
Ether. Option C.
Amide.
Amide.
Yeah.
Amide. A-M-I-D-E. Option D.
Ester.
Esther.
Esther?
Ester.
Esther.
Yeah. And option E.
Aldehyde.
Alcohol. Even though option A and C both have OH group, but in option A, OH is attached to CO. That makes it carboxylic acid. The answer is E, but then we did 5 families here, right? Okay. I got a couple of. I don't have enough printouts. You can take picture. These are few more examples. I don't know if I posted this on Blackboard or not. Just more practice. I can take picture. I have a few copies. I got only 3-4 copies. If you want, we can do this. They're all the same. Front and back. You just move back.
시우면 숨 열어서 그 You want to take a picture?
I just use it to pass this map, so I give it to you. I don't know if you have this on Blackboard or not. But if you want to do more practice questions. And don't ask me what are the answers. Write the product for the yeah. Here I have an acid-based numerical titration based question, but I think this one is, yeah. Acid base, yeah, right here. I have 4 copies. It's a question based on acid-based titration as well as a pH calculation. I don't have enough copies. That's it. This is the last one. I want to keep at least one for now. I cannot keep it. Take the picture. Take the picture of this. I can easily do this. Now, here is another one. Another assignment based on a density and specific gravity. For this one, I have plenty of copies if you want.
Yes.
It's just some questions, practice question. I mean, if you are expert, more practice problem for organic.
Okay.
Take the picture. That's it. If you want, you can take a picture of this one. I want to keep at least one copy so I can take it for this. More just practice, right? It's just more practice. Take a picture.
You.
And you can share. If you have WhatsApp group, you can share. So she was asking, so I gave you a question right now, and you will see question like this in your exam. I will give you the formula for name of organic compound, write down the formula, right? So for example, the one she was showing me, ethoxy, ethane, right? So which family is this? Ether family. So for ether family, you need this, right? So one side is the longest chain is ethane, 2 carbon atom. So let's say this is 1 carbon atom, this is 2nd carbon atom. And now this oxygen will go with this one to make it ethoxy, 2 carbon atoms. And then you need to finish it with hydrogens. This is the structure.
Can you give another example?
Like what?
For this type of question.
For ether?
Yeah.
Let's say if you have 2 methoxypropane, 2 methoxypropane. When you draw the structure, go from back to forward, back to front, right? Last to forward. So propane means how many carbon atom?
4.
3 carbon atom,
2.
right? So 3 carbon atom propane part is done. And now methoxy means O with 1 CH3, right? And on position number 2, so 1, 2, 3. So I have OCH3 here. This is methoxy, right? The rest is just hydrogen.
Where's the O?
Is here? Oh.
Oh.
What about this one?
In the exam, it was ethane, you didn't write H3 on the side. You just wrote CCC. Is it okay?
I would like to see the hydrogens to see that if you know how many hydrogens we need.
This one is 2 methyl 2 propionamine. 2 propionamine.
Yeah, you can do that. This one is correct too.
Okay.
Yeah, no worries. I got so many here.
Oh yeah?
Yeah.
Yeah.
Yeah, take a picture. I got one. Here
Propionamine.
is another one.
2 methyl.
You have this, but then I don't have the answers to these ones. Two carbon atoms. This is ethane, and that's ethoxy with O.
Professor, can you make it on this one?
Longest chain. You can have. So in ether you have two chains, right? In ether you have two chains. Longest chain, propoxybutane. Yeah. Longest chain should be aldehyde.
So this is
So make
oxy
butane.
is the O, right?
Yeah.
Four feels like three.
Yeah. 4 carbon.
Oh, on the left.
Doesn't matter left or right. You can make 4 here, 3 over there. One side 3, one side 4.
Oh, so this is on the one side, this is on the other side. Oh, I got it. I was
Oxygen is a sandwich.
Okay, okay. Oh, this question is good. Oh, okay.
Professor, can you please write that on the skeletons? Skeleton.
This one?
Yeah, because I don't know how to write those.
3 carbons, right?
Uh-huh.
How many carbons?
1, 2, 3.
1, 2, 3.
Yeah.
O. Here is the skeleton.
That's it.
It doesn't matter. 3. O.
Skeleton listed the line.
Ethoxy 18.
Yeah?
2 methoxy. What is
This is 1 from 2 methoxy propane. Ester. This is ester group, right? What do you want to do? Let's say you have CH3, CH2, CH3, and then you have H here. This makes it ester. And when you have ester, this is your number 1. Doesn't matter whether it's longer chain or short chain. Right? And this part serve as your substituent. So what is the name of the substituent? Ethyl, 1 carbon atom, methanoid. Ethyl methanoid.
So always the functional group at the end.
No, especially for the answer.
It may or may not be. Always the functional group at the end is happening in aldehyde, carboxylic acid, and ester and amide. These 4. Aldehyde, acid, carboxylic acid, ester, and amide. These are the 4 functional group where functional carbon gets number 1. Always at the end. You will pass.
What could be the big question, like the 10-point question?
Like part B.
Uh-huh.
Part B here in the sample exam, you have a question based on pH calculations, one question on organic where I give you the name, write down the structure or structure, write down the name, complete the reaction, question based on reaction stoichiometry, question based on molarity, question based on gas laws, right? Reaction stoichiometry, I did it before. Need is equal to given into conversion factor, mole to mole, mass to mass, or mole to mass, right? We did a couple of questions last time. You have it here.
conversion factor?
Yes.
Conversion factor.
Yes. Look at the part B. Any question you want me to do for part B?
Part B.
For gas law question, what you need to make sure
We should convert Celsius into Kelvin
Absolutely. Temperature needs to be in Kelvin scale, period. Volume can be in, volume should be in liters, because if you're using R, gas constant, then volume needs to be in liters. Pressure should be in atmosphere. Right? Make sure, write down all the gas laws side by side when you see the question, so that you know which one to pick. Whether you need Boyle's law, P1 V1 is equal to P2 V2, or V1 over T1 is equal to V2 over T2, or P1 over T1 is equal to P2 over T2, or P1 V1 over T1 is equal to P2 V2 over T2, or PV is equal to nRT. Right? Pressure, huh?
No, any chapter is off.
No one?
Any chapter. Like, does it include in the.
There are few questions on each chapter. Each chapter. How many chapters we have covered so far? Almost every. Right? We did the question based on reaction stoichiometry, organic, lipids, carbohydrates, protein, naming, right? Families, acid base. Right? Do you want to do the pH calculation? It's easy. pH is equal to negative log of H positive, right? Only two formula. pH is equal to negative log of H positive. So you need H positive, then you can calculate the pH. If you have a pH, you need to calculate H positive, 10 to the power negative pH, right? And then the another formula is a Kw is equal to H positive times OH negative. Make sure to do the question based on that. Yes. What is?
What time I use this?
Yeah, you get the right answer.
What question? Whatever is.
The method sheet.
Yeah.
Yeah, yeah.
Yes, I did this one. I remember that.
No, yeah, both way you will get the same answer. There are so many different ways, yeah. Both way you did two different ways. Yeah. Don't do two different ways in the final exam until you first you need to finish the exam. Right? Make sure to finish the exam, then you can try whatever you want to try. Okay.
In the written part, the organic compound, you said 2 times. If you show in the confidence, can I do the structure?
Yeah, yeah.
Is it one?
Butane, right? So butane means 4 carbon atom. 2 butane means you have a triple bond.
Can you do the skeleton?
This is a skeleton. This is a skeleton.
But if I write straight, it will keep it.
You can do this.
Yeah.
This is butane, right?
Yeah, this is also correct.
Then you
right?
need, so how many carbon atoms do you see here? 1, 2, 3, 4.
This is also correct. Right?
Yeah.
That's also correct.
Yeah, it's 2 butane. 1, 2, 3, 4.
It doesn't have to be like this.
Doesn't matter.
Oh, okay.
Normally it's zigzag.
Okay.
Carbons are zigzag. But something, right? So like you, I mean, this is your drawing room. You can set up the way that you
In the
want.
skeletal, if I have a methyl here, I don't have to write CH3, right? CH2 or
If you do skeleton, then you don't have to. It depends
I
upon.
didn't like
yeah.
minus.
I like to see carbons and hydrogen.
Covenant.
I like to see carbon and hydrogen. But if you do it without that, if everything is fine, I'll give you the points. Carbon needs to make, how many bonds carbon needs to make? 4 covalent bonds. All single, 1 double, 2 single, 1 triple, 1 single. Can carbon make 4 bonds with another carbon atom? Carbon
No,
has 4
We have to
electrons.
share.
no.
Carbon share 4 electrons with another carbon. Do you have this quadruple bond?
No.
No,
Why not?
taken a max is 3.
Maximum is 3. But what's the reason?
Because the other side is shared.
Yeah.
Hydrogen.
You have to
Carbon share with carbon. Doesn't need to share with anyone else. Right? But we don't have a quadruple bond. We have single alkane, alkene, alkyne, single triple, single double triple. We don't have this quadruple. Right? We don't have this. Because when you do this, the atoms, they come so close to each other that instead of having attraction, you start having repulsion. I gave you the bad example, right? Covalent bond is a marriage. They share, more sharing, more sharing. Now you're going into my cell phone, you're stalking me, you're checking my phone, right? Time to go. Yes.
And also, benzene means always like, it's like round shape, right? Like cycle shape. But if it's
Benzene.
Benzene, no, but in the exam you say benzaldehyde.
Benzaldehyde. Or so aromatic compound, they are special. This is benzene. This is benzene. This, when you have aldehyde, you have CHO. This is benzaldehyde. Benzaldehyde.
How about if it says benzeketonic acid?
There is no benzene ketonic acid.
Is there an alcohol? If it say
Phenol.
phenol, yeah.
Yeah. Benzene with OH.
Why did
You know.
you use this one?
No.
So this is phenol.
This is phenol. Aromatic compounds. These are aromatic. Aromatic compounds has no rules. They have their own special name, and I told you you need to memorize them. Time to time I was telling you for each family, right? Each family, there are so many, but I told you, okay, just focus on these.
So, I mean, do you think toluene and like benzaldehyde are in the exam?
I don't know. Toluene is benzene with a CH3.
Ozidine, please have an ozidine.
Do you ask your teachers, am I going to have when I have a bone exam, am I going to have an arm bone or leg bone?
Look at you have to memorize so many.
I know. And it's not only you, everyone. So if you don't have any questions, that's it.
Thank you so much.
I'm here. If you have question, ask me. I will not go until you.
Just like,